Welcome back to the Nutrient Management Seminar Series presentations for January 25th. Today, I am pleased to welcome Tom Goddard, who will be presenting on Does Soil Erosion Have a Future in Alberta? Pre-pandemic, Tom was a Senior Policy Advisor with the Agriculture and Forestry Ministry in Alberta. His background in extension, soil science, and field work across a range of agriculture, industry, and government environments has enabled him to translate across disciplines and provide pragmatic solutions to current and strategic issues. Technically, his research has focused on landscapes and scales beyond test tubes and small plots using technology, models, and expert knowledge. At one point, Tom was a provincial soil conservation specialist for Alberta. Now, he is engaged internationally on soils, conservation, farm groups, and policy development. Thank you very much for presenting today, Tom. We appreciate it.
Good day, everyone. Tom Goddard here. I'd like to thank the Alberta Nutrient Management Series Planning Committee and Brad Calder for the invitation to speak to you today about soil erosion, especially wind erosion in southern Alberta. Title of my talk, Does Soil Erosion Have a Future in Alberta? It has had a past, definitely, and I think we've mostly eliminated erosion, but there is still a few hot spots here and there, and so I'd like to give you a bit of a review of the basics of erosion processes and maybe give you some ideas of things that you can use in planning to prevent erosion. The welcome to Alberta sign, we don't want to be looking like this. When we see this sort of scene in Alberta, it indicates that something's wrong in the fields, that farms have not arrested erosion, and we're losing all our valuable topsoil probably to Saskatchewan at this point. We don't have a lot of topsoil, so we have to take care of what we have. Some countries like this in China that has in the Loess Plateau, I'm standing on the right in a typical road cut, so if we lose a meter or two of topsoil, there's more soil underneath to convert and farm stone-free, beautiful soil. That's why they build the terraces up the hills, and also why they don't get too concerned with some of the massive soil erosion that's existed there in the past. They are concerned now and doing things for it, because as FAO reports that in arable lands and overgrazed systems, the natural background levels of erosion, sort of the natural processes, can increase up to 1,000 times, so way beyond the potential of soils to replenish themselves. Alberta doesn't have a whole lot of topsoil. Here's a black soil from central Alberta on the left. And you see we only have about a 30-40 centimeters or a foot and a half of topsoil on it. The graphics on the right are just all the different soil orders and the variation of topsoil, or the black AH that we have, and then the various subsoils below that. In southern Alberta, it's even worse, I guess, that we only have about 10, maybe 15 centimeters of topsoil, often 10 or less. And if we erode some of that, even half of that, we're down to just a couple inches of topsoil, and that is then mixed into the subsoil and creates more variation in the field, which is not what we're looking for. Soil erosion costs a lot. This is west coast of Oregon that I visited and looked at this community where wealthy people built fancy homes on the coast, but forgot about the wind erosion, and regardless of what they did to try and arrest it, it took over the neighborhood, and you could walk through this neighborhood a decade after it was built, and it was like a ghost town. It was uninhabitable. So the costs are huge for society. This is back in China, where they're farming the plains at the bottom of the valleys. And all the gray material you see here is rocks. They actually place a rock mulch on top of the soil to protect against wind erosion and to conserve moisture in the soil. Before they plant a crop, they go through and kind of windrow these rocks into windrows, plant in between, spread the rocks out again. So again, a huge cost to farming, to agriculture, to prevent erosion, and this is the type of thing that no farmer wants. Even in Alberta, we don't want to incur the extra costs of preventing weight erosion, but likewise, we don't want the extra costs, ongoing costs of erosion. I can't talk about erosion without bringing in physics. Kinetic energy equation that you all probably had in grade school is the energy is proportional to the mass times the velocity squared of something. So it's important to look at this as not a linear issue, it's an exponential equation. So as the speed doubles or velocity doubles, the energy in that increases 4 times. This is why we're concerned about wind speeds and hurricanes. This is why you being outside feeling gentle falling rain versus wind-driven rain kind of stings. Same thing with hail. It's not bad when small hail particles are falling, bouncing along, but when those large particles, larger mass, fall, it hurts. And when those larger particles are driven by wind, damage occurs. Same thing with soil particles in a field. When it's blowing across a field, there is more energy in those particles. They become like little bullets. Here's a graphic of the wind erosion process. Same sort of thing that occurs as in water. Just think of water as a very dense fluid. Air is less dense. We have the wind profile on the left. Keep in mind, as we're close to the surface, your wind profile or wind speeds, velocities are less. As we go above the surface, they get higher. Extreme cases this is why we have wind sensors on 10-meter towers on official met stations, because we want to get above the influence of the ground. Also why when we're out on the prairie and it's a windy day, you can lay in the grass or lay on the surface and it doesn't seem as windy, because it isn't. The wind speeds are a little bit less there. But these winds blowing over the top will suck these particles up into the air column, which is faster as you go above the surface, and it blows those particles over into what we call a saltation. So these particles come back down with energy, more energy, because they're at a velocity now. The kinetic energy hits the other particles, dislodges those or breaks them apart, and they go up into the wind column and bounce across the field. The fines go way up higher because they're lighter and off to Saskatchewan or somewhere. And those are the fine particles that are the life of the soil, the organic matter, clay materials, those sort of things. And these particles then get deposited in these tiny little swales or the microtopography out in the field. So again, it's unevenly distributed across the field. And increases the variability, which again is the grief for many farmers. So erosion is a sorting process. Saskatchewan gets the organic matter, we get the sand. Not that great a trade. An uneven process is soil erosion. So the hills and the bumps lose more. It's deposited in the swales, and this is either in a micro sense or macro sense. Doesn't matter. The swale can be a ditch. It could be just a dimple in the field. Erosion has areas of focus. The hilltops, the sandy parts of the field, the exposed parts, all these sort of things create the focus areas where it starts. It usually doesn't start across the whole field at the same time, but starts in these focus areas, and then the saltation and creep get it moving further and further. The result of erosion is a degrading process, both in the current sense, because you're left with little sand pockets, and the loss of the future potential of your field. The productivity, the nutrients, degrades the whole field because you end up with more variability than you started with. Also reduces the resilience or the ability of soil to withstand future impacts of weather and climate. And the degradation is across everything: nutrients, breeding zone, water hold capacity, and all the derivatives from that. There's a study that was done in Saskatchewan many years ago where they looked at farm fields across the province, looked at their wheat yields in the different moisture zones. So in a particular moisture zone, you have this huge range of yields going up and down the left axis here. So in, say, the 20 centimeter, 8-inch zone, of total water use, you've got everything from 0 to maybe 50 bushels per acre. And the difference in all of this, in these yields, is called by what they call the yield factors, which is this list here. That farmers say this is what's causing my yields to be decreased. I've asterisked the erosion, the named erosion, as a yield depressing factor, but a lot of these other factors, probably more than half, are consequences of eroded soil, sort of that extra cost of it, the degradation. So it removes nutrients. The erosion process is removing nutrients, and even though we try and put fertilizer back, it doesn't replace everything. It kind of masks, or it's a band-aid effect. Dr. Bill McGill from the University of Alberta looked at the prairies and acknowledged that yes, that over the years, prairie yields had increased, but at a cost. The cost is by these factors of increase of NPKs nutrients, at least double the requirements of those nutrients, as much as 75 times the N applied was needed or used in the prairies. So again, overall, the cost of degrading of land and loss of organic matter, etc., is costing. Another experiment in the central Alberta a number of decades ago, there's all these scalping experiments done in Alberta, including southern Alberta. The two left bars show the infiltration, the dark bar, and the lighter bar is the yield. So the 0 is the normal background level. Then the middle two bars are minus 10 centimeters. We take 10 centimeters off. Remember, this is in the Edmonton area, so we've got more topsoil to begin with. But even though the infiltration doesn't change, the removal of 10 centimeters of topsoil, the yields dropped in half. Taking 20 centimeters of topsoil off reduced both the infiltration by more than half, and you ended up with only about a quarter of the yields. So again, the long-term consequences of this, how much of that can fertility replace? A little bit, but it is a permanent cost to farming. So in some landscapes, this progressive ongoing cost of erosion ends up with very almost like inland deserts or sterile environments that are huge. Another scientist that was working in Lethbridge a number of years ago basically restated ounce prevention is worth a pound of cure type of thing for erosion or eroded soils. It's cheaper to prevent, even though it might seem very costly to prevent erosion. It's still cheaper to do that in the long term than facing the consequences of it. Put in the picture on the far right, which is a bean field in southern Alberta, again to show, in this case it's salinization, but if you let erosion occur, it can catalyze or exacerbate the issues of other degradation processes such as salinization. And again, it all appears as patchiness in a field, not uniform, so creates more grief for agronomic and field management. In the 60s, we came up with a first generation of wind erosion equations. The top one is a water erosion equation. The bottom one is the wind erosion equation. I've translated the hieroglyphics there, the abbreviations, into words in the boldface. So soil loss is a function of the erosivity of the weather, how erosive it is, and the erodibility of the soils, how they're predisposed to erosion. And the rest is the landform and farm practice in place. So as a farmer, you have control or ability to influence all of these practices, except perhaps soils. You even have the influence to affect the erodibility or the erosive, the prone to erosion of the soil conditions. So you have a lot of factors at play here, and keep in mind they all predispose your field to soil loss. Going to talk about both vegetative considerations and non-vegetative. The first, vegetation, I've split into what I would call sort of regular cropping, cultivated cropping on the left, and the more sort of destructive row crop harvesting of things like potatoes, where it's kind of total disturbance. On the left side, yeah, of course, perennial are much better than annual crops for reducing erodibility of soils and landscapes. Doesn't have to be permanent perennial. Perennials in rotation, maybe, or biennials, that sort of thing. No-till and mulch cover are the secrets to so many things, nutrients, as well as erosion prevention. Anytime you till, it opens up the soil to erosion risks. The mulch cover is important to protect the soil surface from the erosive forces of whatever, rain, hail, wind, all of them together. When you're planning out your cropping system, pay attention to root biomass in erosive areas or areas prone to erosion. Go for maximum root biomass. Look at alternating or alternate root morphologies and composition. The carbohydrate composition of roots will make them decompose at different speeds, different rates. So keep these things in mind. Alternate the height of your biomass or the biomass crops in terms of the biomass that they produce. Come across farmers that will seed or change their rotations, change their field shapes so that they have higher biomass crops on areas that are prone to erosion. Do that sometimes forever, sometimes for a period of time until their field is evened up, and then revert back to the other rotations. Look at extra care on focus areas, because again, erosion starts on focus areas. Go after the hills and swales in case of the water erosion, hills in case of the wind erosion. I've seen farmers that use things like winter feeding practices, feeding on the hilltops, putting manure on focus areas, grass waterways, and the focus areas for water erosion. The right-hand side, if you are doing sort of the complete destructive row crop harvest, then look at getting some kind of cover there. I know Andrew Verhallen is going to be giving you all the answers on cover crops. I'm not getting into the do's and don'ts and the details and the varieties, but just keep a few things in mind here of seed at harvest or before harvest or after harvest, and look at aerial seeding if possible. It's maybe a way to get a lot of seed on quickly without trafficking on your field. Look at irrigation in possibly when you plant it. And again, it's all dependent upon how much time is left in the season. Extra attention on those focus areas if you can't do the whole field. Look for quick germinating, cold, weather-friendly type species that will work. Again, maximum root biomass if you can. The above ground biomass, it might look nice to look at, but once that goes through senescence and dies off, there's probably not a lot there. The roots are what holds that soil from moving. You also have to look at whether you want an annual that will winter kill or a winter crop that will have you have some spring growth, but maybe need terminating before seeding the following year. So keep these factors in mind when you look at the vegetation. The physical conditions I've split to on and off the field. If you're on the field, look at bale shredding and then hairpinning that straw in the ground so it stays put. Manure spreading if you have manure, maybe old rotten bales if somebody has those. It can be either placed or spread. Grass strips for grass waterways or areas where water flows off the field. And, we often don't think we have a lot of rain or a lot of snow, but it will concentrate. Snow melt runoff will have the water running off frozen soils and scour out these swales. Look at irrigation, both fall irrigation or spring irrigation, if that's necessary to keep the soil there. Extra care on the focus areas you have. Look at wind fence or some kind of physical barrier. I've seen people put the small square bales out in the field. Different wood fence, plastic wind fence, whatever in those sensitive areas, not across the whole field, of course. And the right-hand side here, off-field, if it's water issues, look at the sort of water diversion, keep that water from concentrating in areas, control it. Water catchment to hold the water, let it run off slowly. In the wind erosion areas, we're looking at shelter belts in the field perimeter. So again, it may not be the field you have that has the problem. It might be the field right adjacent to it that presents a better opportunity for a shelter belt or some tall grass at the field boundary, wind fence, those sort of things. So the tall grass and the wind fence can be on the field boundary of the field in concern rather than in the field, or it could be both. So again, look at the individual field plantings of grass here, just as a reminder, when you are planting barriers out, whether it's wind fence or grass or shelter belts, we talk about the height of it. The rule of thumb is assuming 50% porosity. Again, this can vary, and that's one of the dials that can be changed. But for a given height, downwind, the area is protected is at least 10 times that height. So 10-meter height would be 100 meters downstream. It would be protected, and as well as upwind one height. So if it's 10 meters height, you got 10 meters protection upwind. Of course, winds will sometimes be blowing both sides, as we see in this picture, snow on both sides of the grass. This is different depending on sort of wind speeds, velocities, porosity, that type of thing. So again, barriers may be something that it is reasonable to use in a field, again, on the focus areas, not maybe on the whole field, but in sensitive parts. Because again, it's protecting what's there, may also be rehabilitating and being subject to erosion over the years. We'll end with some useful planning tools here. Weatherdata.ca is the provincial weather record center, which you can go in and look at your local stations. You can look at regions. You can customize. You can ask for specific things. So you can ask for what's the probability of frost for every day in the month of November or October or April. You can also ask what the cumulative growing degree days are for your area, or maybe for a particular month. In your areas, how warm might it be in the fall? What's the risk of frost? Those sort of things in planning out your crop or knowing what your options are late in the year or early in the year. The soil information viewer comes with 1999 year 2000 orthophoto as well. You can click on the layers that allow you to look at the spot high resolution satellite imagery for the same field in 2015-16. So if you want to do comparisons over 2 points in time, that's a quick way to do it. It also has tools that landowners, you can mark up your fields with polygons that will tell you what the areas of those polygons are, the distances between 2 points on the pictures, linear distance, that sort of thing. So you can mark all this up and save it as a PDF on your own computer. So again, for planning out possibilities of what can be done in these focus areas, useful tool. It also tells you everything about the soils, how they fit on landforms. If you're a soils consultant, you can probably understand better or get into the DBF files for soil layer files, soil names files, and get into details of the soils and potentials that are there on a field. Alberta has the best air photo library in the country, so you can go back to air photos for your farm back to maybe as early as 1949. You can get custom scans or prints from that. All the products are, I think, less than $25. I think that's about the most expensive. Records and spreadsheets, keep that in mind. So all of the factors I was talking about earlier, you can put into a spreadsheet as rows or columns, and then the other side of the spreadsheet, you can look at different crops, different strategies, plan that out, give yourself a number of, I don't know, 1 to 5, and tally it up so you can score the different options that you have. Also use these type of your own personal templates to record the results of what you're doing. That's important. So what future do we want in Alberta? The left side and the right side, they're both pictures from southern Alberta. And we need to pay attention to what the public are thinking of it. We're getting a lot of public opinion out there of how farmers are farming and sustainable practices, livestock, land use, all of that type of thing. The corporations are starting to move in now with sort of sustainability requirements, farm practice. So we want public to see and appreciate what farmers are doing on the right-hand side here, which is a picture, I think I got this from Rob Dunn, of potato field with a fall cover crop on it. There's also the Soil Conservation Act, which in Alberta it comes under criticism, it comes under accolades too. I have said at times defending Alberta to corporate interests or foreign markets that we do have the Soil Conservation Act, which can be implemented by the counties to encourage or enforce, proper controls. And a lot of countries, a lot of industries are very impressed with that. Just the fact that we have it, that we've thought about this for years, and maintaining sort of a due diligence. So again, it's the part of everybody, I guess, to maintain due diligence. The risk for erosion, the weather conditions that we have are probably not going to get calmer in the future, so we're going to have more extreme weather. And we need to be paying attention all the time. Keep your guard up. With that, I wish everybody a successful 2021. It's got to be better than last year, and I hope that we have an excellent farm year ahead of us. Thank you.